solid design pattern is really important to learn as a software developer. So whenever you're writing your code, you should always follow the solid design pattern and you should adhere to it. It will allow you to create a very robust code and a really scalable code as well. Hey, what's up guys, and welcome to Daily Code Buffer. In this video, we are going to go through the solid design patterns and we are going to particularly learn to identify what is going to be the bad code and how you can improve the code based on these principles. So I have just laid down the few examples here. So I will show you the examples, and with those examples we will understand what is going to be the good code and what is going to be the bad code. And accordingly, whenever you're going through the code, you can identify how you can improve the code readability, how you can improve on your code structure and everything based on the solid design principles, so you can improve your coding as well. So let's identify the code, and this will also help you to prepare well in your interviews as well. So we are going to create a complete series out of it where you will learn each and every design patterns and all the low level code as well. So as always, keep supporting. So let's first understand what are the different principles here. So in the solid principles, we have 5 acronyms: SOLID. Let's start with the S. S stands for single responsibility principle, which means that whatever the classes that you create should only have a single responsibility. Now, whatever the classes that you create, all those classes should have only one responsibility, and that responsibility only should be followed by that particular class. Now, how to identify that this particular class has a single responsibility or not? You just need to ask the question like what this class does. And if you encounter "and", that means that is not a solid design principle. It is breaking the rule, because you cannot have this and this both can be implemented by a single class. Okay, it should only do one thing and it should have only one responsibility. I have the example with a good code and a bad code as well. So let me just show you that. So if I open here in the solid principles, in the SRC, I have kept all the code over here. Okay, so let's go with the single responsibility. So in the single responsibility, you can see that I have one account class available. Okay, this is the Pojo, where I'm just storing the account information, which has the account number, first name, and the total amount in the available account, and all the getter setters and everything. Now if I go to account operations class, okay, in this account operations class, you can see that this class is created to do the operations on the account. Okay, what are the operations on the account? To add the account, to get the account details, and to update the account information. So that's the work of the account operation class. Okay, but here you can see that there is also a method called deposit. So the account operation class is only responsible for account related operations. The deposit operation, that you can tell that that's the transaction operations. Okay, depositing the amount or withdrawing the amount, that is the transactional details on that particular account. It is not the account operations. So here you can see that this is violating our principle that account operations class cannot do account operations and deposit or withdraw, or that is a transactional details, right? So this is breaking our single responsibility principle. So what we should do is we should create another class that handles the deposit. This account operation should only handle our account related operations. So for that reason, what I have done is, you can see, you can go to the transaction operations, and in this transaction operations, you can see there is a 2 method. There is a deposit method and the withdraw method. So this way you should segregate the responsibilities. Your account operation should only be doing your account related work, and your transaction operation should only be doing the transaction related stuffs, that is the withdrawing the amount and the depositing the amount, and whatever the other operations that needs to be done as a transactions. Okay, so this way all the class should have only single responsibility, and whenever you encounter "and", that's the violation of your principle. And if you go to the main class, you can see this way you should be calling it. You create the object of the account and you set all the details of the account, and with the account operation you add the account, and with the transaction operations you deposit the money or you can withdraw the money, whatever the transaction needs to be done. So both the things are separate. Now the next acronym is O. O stands for OpenClose Principle. That means any class or any interface that you create should not be open for the modification. Okay, it should be closed for the modification. Whatever the extra functionality that you need to add, they can extend the class and then you can add the any functionalities to it. Okay, so suppose you create a class and no one should be able to add any extra method to that class. Whatever the extra method or extra functionality needs to be added, a new class should be created for that particular functionality, should be extending that class, and then we can have the extension to the particular class. So we should be closed for the modification and extension should be allowed. So let's see the example with it. Let me just close all these methods here and let's go to the open close principle. First, let's go over here. So here you can see that I have created a calculator class. This is a bad calculator. Okay, let's go by going through the bad code. So in this calculator, what we are doing is we are just passing two numbers, and those two numbers, in that we are also passing one type, what we want to do. So here you can see that with a switch statement we are doing everything. That means if we are passing sum, then we are doing the sum. If we are passing sub, we are doing the subtraction, and that way. So here you can see that for each type, whatever is passed, okay, we are doing the switch cases. Now suppose if you want to add new operations like multiplication, division, then we need to come here and modify our code, right? So that means that's the violation of our open and close principle. We should not be allowed to modify our classes or objects that has been created. We should only allow to extend it. So this design violates that principle. So let's see how we can overcome this scenario as well. So if you come over here, what we have done is we have created one class that is operation. Okay, this is the interface that we have created, and this interface you can see will perform the operation. So this operation will be performed by the two numbers. Okay, now what we will do is this operation will be extended by the two class, that is the add operation, which will implement the operation, and it will do the addition operations. It will just implement the perform operation that was mentioned in the operation interface. The same way it will do for the subtract operation as well. That subtract operation will implement the operation interface, and it will implement the perform operation where we will do the subtraction. Now you can see that the operation interface that we created, and that interface is being used by the two classes, that is the subtract and the addition. Now if you go to the actual calculator class, you can see that now it's really simple. We just have a calculator and we are just doing the calculate number, and we are just passing two numbers, and then we are just passing the operations. Okay, we are not doing any switch statement or anything. The operation is passed and the operation.perform method is been called. Now whenever we will be passing the add operation, addition will happen. Whenever we are passing subtraction, subtraction will happen. And if we want to introduce the new functionalities like multiplication and division, we can just extend the operation class that we have created, implement the perform method, and in that perform method we can write our logic that it's going to be multiplication or it's going to be division. And whenever from the calling method, that is the calculate number, at that time we will pass the division operation or the multiplication operation, and that code will be executed based on the perform method. So you can see that we are not allowing to modify the existing method or existing class. We are just allowing to extend the functionalities. So that's how we should be thinking in our mind, that how this principle should act in our projects as well. So this way we should think about, okay, whatever the class or interface that I have created, is it designed in such a way that whenever the new functionality is coming, I am modifying this particular implementation or not, or I am allowing to extend this and a new functionalities can be created based on the business logic. So that way you should keep in mind and design our code. The next acronym is L, that stands for LetsGo Substitution Principle. Now LetsGo Substitution Principle states that whenever you are creating a parent-child relationship, that is the parent class and the subtype class, so both the class should be interchangeable and should be substitutable. So that means whenever I pass the object of a child and whenever I pass the object of a parent, both should work. The code should be able to handle those scenarios. So we should be able to substitute our classes whenever we are passing the objects of it. So let's see an example what it means. So if I go to the LetsGo here, let's understand the bad design first. Now you can see that I have a loan payment Java class. Okay, this is the interface created. Now this loan payment, you can see that there are multiple methods available. That is the do payment, force close loan, and the do repayment. Okay, these three methods are created. So these three methods needs to be implemented whenever I am creating a new class out of it. Okay, so this loan payment can be implemented by the home loan and the credit card loan. So both are the different types of loan, and both of them can implement this loan payment. Okay, so let's see first example of a home loan. So in the home loan, you can see that home loan is implementing the loan payment, where it is implementing the do payment, force close loan, and the do repayment. All the three methods are implemented here. There is no issue. Now if you go to the credit card loan can implement the do payment and the do repayment, but it does not allow the functionality to force close a loan. Okay, so that's why you can see that it is throwing the unsupported operation exception. Now if you go to the loan closure service, now in this loan closure service, you can see that we have added the loan payment, that is the loan payment interface that we have created, and it has the force close loan. Okay, so which in turn calls the force close loan method of a class that we have provided. Okay, so whenever I am passing the home loan over here, okay, at this particular point, so from that home loan I would be able to close a loan. Okay, because I have a method available to force close a loan. Okay, but if I pass a credit card loan, so whenever I'm passing credit card loan, it will throw the unsupported operation exception. So that means you can see that whenever I am passing the child classes one or the other, I'm not able to fully pass it. One of the operation is not performing, right? So that should not happen. Okay, we should make sure that whatever the classes or whatever the implementation that we provide, all those should be substitutable. Okay, so let's see how a proper code we can do for this scenario. So if you go to the good code here, what I have done is I have created a loan payment interface which will just do the payment. Like whenever we are doing loan payment, it should do the payment. So from this loan payment, I created the another class, that is the secure loan. Okay, secure loan means we need to take the money back. So in that you can see that I am doing the force close loan. So you can see that I have made sure that whatever the methods are available, those methods are only I'm keeping in the interface. So loan payment is doing do payment and secure loan is doing the force close loan. Now if I go to the home loan, this home loan is implementing secure loan. Okay, now whenever the home loan is implementing secure loan, that means I can do the payment as well and I can force close the loan as well, because secure loan is having the method that is called force close loan. Okay, if you go here, secure loan, this is only having the method that is the force close loan. Loan payment doesn't have that. So home loan has the capability to secure the loan, but credit card loan does not have the capability. It will just implement the loan payment, like we can just do the payment out of it. So now if you go here loan closure service, you can see that it is just taking the secure loan. Okay, so whenever I'm passing this secure loan, it will have the force close loan method and this will be executed. So you can see that whatever the implementing class of the secure loan would be, that we are going to pass, or we can pass the secure loan and everything should work properly now. This way you can see that we just change our code so that it will behave properly whenever we are substituting the classes. Okay, earlier you can see that earlier in the bad code, whenever we were substituting the classes, it was throwing the exception in one of the methods. Now but here we just change the behavior itself, like the loan payment can be only do the do payment, but secure loan will do the force close loan. Okay, it will take the payment back as well. So whoever requires that functionality can go ahead with implementing the secure loan and that way the code will work. So this way we should think about whenever we are implementing this principle. Now the next acronym is I, that stands for interface segregation. Okay, so we should create the interface in such a way that those interfaces should have a proper methods that needs to be implemented. I should not create an interface which have hundreds of methods, but a client does not require all those methods to be implemented. We should not force the client to implement all the methods which are not necessary to them. We should segregate our interface in such a way that whatever the interface has been implemented by the client, all those methods should be relevant to that interface. Okay, so we will see in the example how we can achieve that, but we should allow the client to implement those methods such a way that it's not a bottleneck for them as well to implement all the methods. So let's see with the design here with the code. Let's understand the bad code first. Okay, here you can see that I have created the DAO interface here, and this DAO interface, what we are doing in this DAO interface is, DAO interface we have created such a way that it can access the file system as well and it can access the DB system as well, and with both of them it can do the operation. Either it can open the file as well and it can open the database connection as well, and after that it can create a record or delete a record. So all this particular method declaration that we have done, that it can open a connection in DB, it can open a file as well, it can delete a record and it can create a record. Now if I go to the DAO connection, okay, this DAO connection is implementing bad DAO interface for the database. Okay, so in the database I can open the connection, I can create a record, I can delete the record as well, but I cannot open a file because it's a database connection. I'm not worried about opening a file. So whenever I'm opening a file, we should not allow to open a file. So that's why you can see that we are throwing the unsupported operation exception. Okay, so that's the violation of the principle, that we are forcing the client to implement a method which they don't require. So here open file they don't require, right? They have to work with the database. So open file should not be here. If I go ahead with the file DAO connection, you can see that I can do open file, delete record, create record from the file, but I cannot open the connection because that is not what we are doing. We are not connecting with the database, we are connecting with just the file. So that's why this method is not relevant here in this particular implementation. So let's see how we can improve one. So if we go to the here in the good package, what we did is we segregated the interfaces. We created one interface, that is the DAO interface, and this DAO interface just have two methods. That from this DAO interface, either you can create a record or you can delete a record. Okay. And on top of that, what we did, we created the DB interface. Okay, and this DB interface will allow you to open a connection to the database. Okay, that's only one method we have defined, and we have created the file interface which will allow you to open the file. Now you can see that all the interface have the different methods and appropriate methods as well. Okay, now whenever we want to implement the file system, right? So if I go to the file system, file DAO connection, what I'm doing is I want the DAO interface. That means I want the create record and update record functionality, or delete record functionality, plus I want to interact with the file. So that's why I'm implementing two interfaces, that is the file interface that will give me open file functionality, and I am implementing DAO interface which will give me delete record and create record functionality. Okay, similarly if I go to the DB DAO connection, I am implementing the DAO interface which will give me the functionality of delete record and create record, and I am implementing DB interface which will give me functionality to open a connection to the database. So you can see that how neat it is. Like from the implementation part itself, we will get the understanding, okay, what is this interface doing, what is this interface doing. Both have their own responsibilities, and whatever client needs, client can implement those interface. Those implementation can be added by the client according to their requirement. Now we are not forcing the client to implement or add the implementation of any classes or methods. Now the next acronym in the solid design pattern is the I. I stands for dependency inversion. So which means that we should not be having the any dependency on any modules or any sub modules. So higher level modules should not have the dependency on the lower level modules or the classes or objects of it. Okay, we should design in such a way that it should not have the dependencies on each other on the different classes and objects. So let's see with the example, so we'll get more understanding. So if we go here in the bad design, we will take the example of the same calculator that we did in the OpenClose principle. So here you can see we have the calculator, and in this calculator you can see that we have the calculate method, and in this calculate method we have a switch operation where we are passing the operation. So whenever we are passing the add, I am creating the object of a add operation, and whenever I am passing sub, I am creating the object of the sub operation. Okay, simple thing. And I have the add operation and I have the sub operation. Now you can see that with this design there is a flaw, because you can see that what we discussed was your higher level module should not have the dependency on your lower level modules. Okay, so your higher level module is your calculator. Okay, that's the calculate method, and this calculate method has the dependency on the add operation and the sub operation, because you are creating the objects of those here itself. You need the object of the add operation to be created to use that in your calculate method. So that means you are not doing the dependency inversion. You have the dependency that you need or you are creating by your own. So what we have to do is we have to change in such a way that we are not directly dependent on the classes or objects that have been created. Okay, so for that let's understand the better way. So what we are doing is we created the add operation here, right? So this add operation is implementing calculate operation. So we just created one calculator operation here. Okay, this is the interface, and what calculator operation will do is calculator operation will have one method that is calculate. Okay, it will take two numbers and it will do the calculation based on the implementation that we provide. So this calculator operation is been implemented by the add operation. You can see this is implemented by the add operation, and this calculate method is doing a plus b. It is also implemented by the subtraction operation. Okay, subtraction operation implements calculator operation, and it is doing the calculate method with integer a, integer b, that is a minus b. Now if we come to the calculator, you can see that we have no dependency. What we are doing is in the calculate method we are just passing the two variables, that is the int a and b, and then we are just passing the operation. Okay, we are not creating any objects or anything. Whatever the calculate operation that you pass here, either you pass add operation or sub operation, that will be calculated directly. So now in the future when you add multiplication operation or the division operation, you just go ahead and implement the calculator operation interface. You give your implementation, and whenever you're calling the calculate method, you can just pass that division operation and it should work. So you can see that there is no dependency available. Everything will be handled easily here. So you do not have to go ahead and create different objects based on some other conditions. Everything will be handled with the interface itself, and that interface you have to implement based on your requirement. So now you can see these are all the things that we learned about the solid design principles. This will be very helpful in your interviews as well, because in the interviews this is the standard question that you will be asked as a software engineer role, that what is solid design principle and how you should be implementing your code. And whenever you are going in your LLD design level rounds, at the time also this type of things will be taken in picture whenever you are being evaluated as well. So make sure that you understand these concepts very well, because concepts is important, and whenever you are implementing your code, make sure that you recall these concepts and accordingly you design your code. I would always suggest that don't directly jump into the code. First design it, like what methods you will be requiring, what particular interface, objects and all things you would require. Design it on paper or draw.io or anything. Just get the visual understanding, and then it will be very easier for you to implement your code as well. So that was all about the solid design principle. If you have any doubts or anything, as always, you can ask me in the comment section below. If you like this video, give us a thumbs up and subscribe to my channel for the upcoming videos. You can also join our channel to support us as well. So that's all in this video. We will be doing a lot of videos for this series. So I will see you in the next videos. Till then, happy coding. Bye bye.